So let's just look at this small concept of kinetic theory. It's actually very important because it can be found in physics to also explain almost the same thing. So the kinetic theory of matter is an important concept because it will also appear in some other topics later on in your chemistry classes. So what we are interested in as of now is how it explains the behavior of particles in the different states of matter. And that's the main goal of this presentation. So matter consists of particles, okay? And these particles are arranged differently in the different states of matter. That is in liquids, gases, and solids, okay? So in our presentation, we saw that in solids, the particles are very close and they are having strong forces of attraction. And also in liquids, a little bit apart, but still have weak forces of attraction. And then in gases, the particles are widely apart with negligible forces of attraction. Okay? But how do these particles behave according to the kinetic theory of matter? Okay? The kinetic theory of matter helps us understand how these particles behave when whether they will remain in one fixed position or whether they actually move around, whether the forces of attraction can be weakened because of temperature or not. Those are the things that the kinetic theory of matter helps us to understand. So, if we ask you about the kinetic theory of matter, explain the kinetic theory of matter, you should be able to say that according to the kinetic theory of matter, matter consists of particles that are in constant motion because they possess energy, what the energy called kinetic energy. And this basically explains some of the things that we see in the different states of matter. Okay, so the kinetic theory of matter states that matter is made up of particles that have that are in constant random motion or that are in constant motion. Okay, because they possess kinetic energy. Kinetic energy is that energy that is possessed by organisms that are in motion or objects that are in motion. Okay, so this is basically to illustrate the particles. Okay, these particles are not fixed in one position, but they are always moving around. Okay, that is the kinetic theory of matter. Constant motion because they have this. Okay, so we can be asking you to explain, for example, freezing according to the kinetic theory of matter. What happens in freezing according to the kinetic theory of matter? What happens in vaporization according to kinetic theory of matter? So those are different questions that can be phrased, but just know that kinetic theory of matter explains all this clearly. So in solids, the particles are closely packed together with the strong intermolecular forces or with strong forces of attraction between them. Okay, that means that for them they are not moving freely, but if you subject them to heat, they can vibrate, but also these forces can be broken. Okay, and you can still have the solids transitioning into a liquid state where the particles are a little bit apart. That is what kinetic theory is saying. For liquids, we know that the particles are a little bit free apart, but they still have some forces of attraction in between them. Okay, and that is why these particles can freely flow, okay, and can take up the shape of their container, and that is why we have them apart here. And then for gases more apart, free to move, negligible forces of attraction, or very weak forces of attraction. That's why they can move in any direction. In any direction they feel like, and they can fill the space of any container they have. They don't have a definite shape and volume. So let's look at how the kinetic theory of matter explains some of these things like melting, freezing, condensation, evaporation, and the rest. At melting point, when you heat a solid, at melting point the forces of attraction are actually broken, and that means that the particles can now flow or move just like what happens in liquids. Okay? So when a solid is heated, the particles gain kinetic energy. That energy weakens the forces of attraction. That's why they let go and the particles become freely moving, just like what we see in liquids. And then when it comes to evaporation, still when you heat the liquid, those moderate forces of attraction are actually also weakened. That means that the particles gain kinetic energy and they can now move or escape from the surface of the liquid, thus turning into a gas. Okay? So that is how kinetic theory explains evaporation. That when you heat a substance, a liquid, the particles in the liquid gain kinetic energy, and that kinetic energy is very strong enough to allow these particles to escape the liquid such that they become a gas. And then with condensation, when you cool a gas, the particles lose the kinetic energy, so they cannot move very fast. So they slow down and come closer, just like what you see in a liquid, where the particles are a little bit closer with some forces of attraction. And then with the freezing, when you cool down further, the particles move more slowly and more closer, increasing the forces of attraction between them, and therefore transitioning into a solid. So that is the kinetic theory of matter, which explains how matter changes from one state to the other based on how kinetic energy is gained or lost. When we have particles gaining kinetic energy, they move more rapidly. Okay, so we shall have issues like evaporation happening, where the particles gain enough kinetic energy to allow them escape the surface of the liquid and therefore become into a gas. But when the particles lose kinetic energy, when exactly what happens when cooling is taking place, they lose the kinetic energy, they slow down, okay, and they come closer and increasing the forces of attraction in between them. And this is what happens with freezing, where we have a liquid turning into a solid. Thank you.